All right. So if you have not, please make sure that you title this 3-1. The big piece you're going to put into your notes today is this idea of what's known as standard form. Mathematically, unfortunately, we often use the same word multiple times, and we're going to see standard form show up a handful of times. The first one, though, that we look at is this idea of a linear function. Yesterday, everything you guys did dealt with linear functions because they're all straight lines. All right. As we move on throughout this year, the goal is going to be to make more piles, so to speak. Meaning, every time we see an equation, what pile does it fit into? Is it something that's linear, meaning it's a straight line? Is it something that's quadratic? Is it exponential? Is it a square root? What is it? As we move throughout the year, our piles will get bigger because we're going to have more things to separate. But for today, at kind of our beginning, we're only going to separate things into two piles, those that are straight lines and those that are not. Graphically, it's super easy. We could all identify what a straight line looked like. Even though yesterday some of you guys tried to talk to me about the length of a line while you were playing that game. Did anybody talk about a short line or a long, right, the one that only saw just a little bit of it? That'd be like me taking a headshot of you and saying you don't have a body because all we can see is your head, right? So if you can only see a little bit of a line, it really is a full line, right? It goes on forever. We just need to realize that we're only seeing a little piece of it. So today, as we get into this idea of being able to identify linear functions, we're going to have to be able to look at them through equation form. And that's what we're going to talk about here with this standard form. So we're going to get into that idea. We're going to get into the idea of finding an intercept. And then we're going to kind of put the brakes on it today. And tomorrow, we're going to shift gears and kind of look at things graphically. So we're going to kind of do them in two parts. All right. We'll let this stuff go for today. These two objectives, we're only going to touch on the first one today. So we're only going after the identification of the equations and the intercepts. And like I said, we'll get into the graphing tomorrow. As you look at these vocab words, though, that we're going to touch on today, do you recognize any of those? And I don't say recognize like I can read them. I mean like recognize them like, yeah, I could tell you what that is. And that sometimes is a big difference. Jack, you got an idea? Beautiful. You want to finish the other half of that while you're at it? Good. So graphically speaking, the x-intercept is where my line would cross the x-axis, and then the y would be where it crosses the y-axis. Okay, what do you got? You just keep saying line, hoping I say okay, right? So graphically speaking, obviously we would say that it's in a straight line. Today, though, they're going to come in the form of an equation, and the goal will be, if I look at that equation, can I recognize that it would be a straight line, essentially without having to graph it? What you got? Um, that's okay. We're actually going to start with standard form. That's exactly where we're going. What do you got, Logan? A number that goes with a variable is actually called a coefficient. I can't understand you. It is not does not include a variable at all. What did you say, Aiden? No. Didn't you say it was a number without a variable? Well, why don't you just say nothing? That's exactly what you said, right? Yeah, that's what a constant is, just a number. Okay, constant means something that doesn't change. And if we put a letter with a number, that variable has the opportunity to change its value, but a number on its own does not. Okay, and so a constant simply means that it's literally just a number. That'll be useful for us today. So, what does a linear equation look like? We know what it looks like graphically, right? I mean, it's a straight line. Kay said 12 times, right? It's a line. But how do I know what it looks like? I think a lot of you guys know a form of a straight line. It starts y equals mx plus b, right? That has a name though. Anybody know it? Y equals mx plus b. Something something form. First one's an S and the second one's an I, if that helps you. Ben? Good. Slope intercept form, right? And it's called slope intercept form because it got two things in it. It's got the slope, which a lot of you guys talked about yesterday, and the intercept. Do you know which intercept it has? Good, has the y-intercept. So I don't remember who told us that a second ago. Maybe it was you, Jack, that said it's going to be where my graph crosses the y-axis. So, for example, if you had an equation that looked like this, y equals, I don't know, let's say 4x plus 3. Would that be a straight line? Yes, it would be, right? It has a slope of 4 or 4 over 1. And we're going to touch on this in a couple days next week. So if you're like, I don't really remember that, that's okay. And it has a y-intercept of 3. And I could plot that and I could make a graph, right? Well, standard form of a linear equation is very similar to this, but it's another way that I could recognize the same information. So it's actually written right here, okay? And so in your notes, I would like you please to write this form. AX plus BY is equal to C. That is what's known as standard form of a linear equation. Meaning, if it looks like that, it's guaranteed to be a straight line. Now, what in the heavens are A, B, and C? Okay, so it's not necessarily what numbers go there, and we'll look at examples of this here in a minute, but it literally is going to be if there is a number here, here, and here, then that automatically will be a straight line. And we'll see more of those here, and just give me 1 second. What's up? I literally can't hear you. Between that mask and these headphones, I got nothing. Well, remember, we're talking linear equations. This is going to be a straight line. It's not going to turn into a shape. Okay. It really, yeah, I promise, you're really overthinking this. Look, these two things right here, what's a number in front of a variable called? A coefficient. That's all they are. A and B are simply coefficients. All right. Numbers in front of variables. That's it. Literally any number. And C is also a number, but when a number is by itself, what do we call it? A constant. So, Olivia, give me 3 numbers. Literally, I don't care what they are. Fine. If the equation said 8x plus 2y equaled 5, okay, that is guaranteed to be a straight line. Okay, and I'm going to show it to you with that calculator that I just talked about a minute ago. If we jump over here to this Desmos calculator, you said 8x plus 2y equals 5. Guarantees that it will be a straight line because it's in the form of ax plus by is equal to c. Those numbers can be anything. Like change 8 to 1 over 125. Still a straight line. Change the 2 to a minus 500. Still a straight line. Like you can make them anything you want. And okay, what about C? It has to be a constant, right? Which means a number without a variable. Could be anything. Could be 0, right? 2x minus 4y equals, and as soon as I put a number there, I get a line. Guaranteed. Now, are you realizing how nice this Desmos program is? I mean, are you seeing, like, the moment I type, boom, answer. Okay. But did you see what happened? Like, if I take this minus out of here, all right, and I had like 1 over 125x. Oh, that doesn't belong there. Sorry. Can I get that out of there? And then I don't even know. 5 over. But I mean, even look at that. As crazy as that looks, whatever in the heck that is, I mean, make this number 4,125. Nope. 41,250. Watch. I just keep zooming out. Eventually, guess what'll happen? I'll find it. Eventually. Somewhere. Where is it? Keep going. Am I getting there? Where are you at? Where did it go? There it is. Right? Now, look. Yeah, look at the units. Right? 2 times 10 to the 6. So a 2 with 6 zeros after it. But it's simply by rolling my cursor or my mouse, I can zoom in or zoom out. But eventually, I was going to find a straight line because it fits the form of the standard form of an equation. Okay? And with those 3 pieces of information, it will produce a straight line, no matter what. Now, if I'm asked to graph, it's a little bit different than me plugging it into a computer and just waiting for the result to show up somewhere. And we'll get more into that idea tomorrow. But what I want you to understand is that if you can recognize it, guarantee it works. Okay. And so in your notes, I'd like you to put these 4 down. And I'll give you a second. But what I'd like you to do is I'd like you to ask yourself how many of those 4 are going to be straight lines? And if they're not, can you see what it is that's going to make them be a no? So take a sec, because this is good. Your homework's going to look very similar to this idea. Obviously, not with 4 in the same problem, but you could almost think about that as like 1, 2, 3, and 4 in your homework. You're going to have 8 of them total. What's up? Oh, you think you know one? So remember, we are trying to base it off of this general, what we call standard form equation. And remember, A, B, and C are numbers. And that number can be positive, that number could be negative, that number could be 0. It's still a number. Okay? So with those 4, can you find me one that works? You're out on that one? Were you going to give me one that didn't work? Oh, well, let's start there then. Which one which one is a no? C is a no? Why do you say that? I agree with you, by the way. Okay. Good. Right. I need a number here. I mean, if I thought about bringing this over, and actually, which letter am I actually missing the number on? It's not B, Jack. It actually would be A, right? Because this would be your B, right? Because it matches your Y. There's your C. But there's something going on here. Okay. And if we jumped back over to that Desmos calculator, we could put that in and find out what it looks like. But I promise you, it's not going to be a straight line. Okay. And so for right now, that's our separation standard. It is or it is not. What you got for me? Well, because B was attached to the Y variable. So, and that was a Y. So, I mean, that's why I would claim it to be B and not A. But really, they're both coefficients. So you're kind of splitting hairs at that point. All right. Okay, so you got 3 others. Give me something, Jack. What you got? A is a no for what reason? Good. There's a 3rd variable in there, right? And so that right there is going to be problematic. So that's also, I would say, is a no for sure, right? So this is, we would say, non-linear. And this one here is also non-linear. You remember when we solved the absolute value equation and we graphed it on a number line? And we plotted that point? That's graphing in 1 dimension, like on 1 number line. When you bring in 2 variables, you start to graph on 2 number lines or an XY axis. When you bring in a 3rd variable, you're now talking about graphing in 3 dimensions on 3 different axes, an X and a Y and a Z. You visualize that? Try graphing on flat paper in 3 dimensions. Yeah, big brain. All right, big brain stuff. It can be done. You can do it. Okay, just takes a little bit of work. What you got, Logan? Logan, you got to speak up, man. You're killing me. B does not work. Why do you say that? Oh, okay. So let's take your first statement. You had originally said it was a no because X and Y were not on the same side. I'm gonna throw that back at you and say, could I put X and Y on the same side? How? Okay. What if I subtracted the Y from the right side and moved it to the left side? That's a legal move, right? So I would end up with a statement that says 3/4 of X, now it would be minus Y if I move the Y to the other side, is equal to 8. Does it look like this now? Yeah. What's the value of A? That's part of your homework tonight too. Can you identify what is A's value? What's B's value? -1. And C's value is 8. Okay? So if we went back over to Desmos and I graphed that, it'll be a straight line. All right? Because it does match. So this is a yes. That is an awesome S. Aiden, what do you got? Like normally? Oh, yeah. If you Okay, so the coloring system there is not as crazy as you want to believe. My line is green. Look up there. See how mine's green? Because over here on the side, it's green. I'll bet you yours is red. Yeah, I can change that if I can remember how. You can change that color. So if I made another equation here, if I came down and I made a new one, like that was 3/4 X minus Y, oops, 3/4 X minus Y equaled, was it 8? It's purple because the little color code over here is purple. And the only reason they change colors like that is so that you can keep track of which one you're looking at. So, not that green is good and red is bad. It's just literally whatever one is there. But you did notice something though, didn't you? When you put in that 3/4 X equals Y plus 8, it still graphed it, didn't it? Okay. I'm not saying that it has to look like this right here in order to be graphed, but if I can make it look like that, I know that it's straight without having to graph it. You see the difference in those statements? What you got for me? Absolutely. Right? That's really in what form right now? And you already know this. Yeah, it's in y equals y equals mx plus b, right? Slope intercept form. But if you wanted it to be in standard form, what has to move? What moves? The x. How do you move the 4x? Ooh, yep, subtract it to the other side. So you get negative 4x if you subtracted it. Now it's plus y equals -5. And so you would guarantee that that would be a straight line as well. Yes, sir. All right, yeah. Say that again. So A was 3/4, Y was, or B was -1. And then that would be, so same thing down here, right? That's -4 for A. This one is just a +1. And then you have -5. Yep. Okay. So that's part of your homework tonight. Nothing, too crazy. The other idea then that we're going to touch on today is this idea of intercepts. And I don't remember who, was it Jack? Were you the one that gave me the definition of an intercept? So based off Jack's definition, he said where the graph crossed either the x-axis or the y-axis. Looking at that picture, which one of those 4 choices is the correct choice? Which one? B. Okay. Nothing crazy, right? If I took the graph away, might be a little bit harder to figure out what they were, right? Think about this for a second. If that's the x intercept right there, it has an ordered pair. What's its ordered pair? Yeah, it's one of those two. Which one is it? 4, 0. Good. Because remember, ordered pairs would go x, then y. What's this ordered pair up here? What is it, Aiden? 0 and 200. What do both ordered pairs have in them? They both have zeros. Why do they both have zeros? Good. They're on the axis, or the axes, if we're going to say them in a plural sense. By definition, an intercept says exactly that. The x-intercept is the value of x when y is equal to 0. And the y-intercept would be the value of y, or excuse me, when y has a value and x is a 0. But they're super easy to identify because they're guaranteed to have a 0 in them, right? So if we look at, we'll skip that one. If we look at this example here, those 5 ordered pairs are small up there probably, but can you tell me right now where the intercepts are? Okay, can you see them? Well, I would not disagree with you, but the ordered pair would be 0 and 200, and then the other one would be 500 and 0. Which one's the y-intercept? Jack, what is it? The top one. Okay. And the x-intercept would be then obviously the bottom one. In relation to this problem about Mr. Peanut, I love Mr. Peanut. I do with his top hat and his monocle, right, and his little cane. You know what a monocle is? Yeah, you got the one eyeglass thing going on there, right? So in their factory, they can bag peanuts at a rate of 4 ounces a second. In this particular example, how much did they start with? How much did they start with? 500? Okay. You agree? No? What do you think? Started with 2,000. Agree? They started with nothing. It would seem very counterproductive as a company to start with nothing if I was bagging peanuts. I mean, we don't got to take them to the Tribe game because they took the L last night, but, at some place you might want peanuts in a bag. Shout out. What? Hold on. What are you thinking?
Because it's going down because they're packing them in the first second and the seconds increase.
Okay.
So that means that the ounces are different.
Okay. So if the time is at 0 and the weight is at 2,000, then that's really the beginning of this process, is it not? How long did it take for this process to run? 500 seconds, because I've got a max time and I've got a 0 at weight, which would imply kind of like a beginning and an end in this scenario, right? So if I was thinking about this graphically, I heard the phrase that it was decreasing, right? And in this case, if you thought about your 4 quadrants, what quadrants would this graph be in? Jack? Just the first one. Because if you get outside of the first quadrant, what do you have? You got negatives somewhere, either in the X or in the Y or in both. And we're talking about time and we're talking about weight. I don't think either of those things are going to go negative on us. So even though the line would continue, we're kind of going to knock that off at just those 2 points. All right. Last one. Take a second, read these 3 pieces. Let's see if we can get all that on there. And then we'll put the brakes on for today. Am I blocking your path? I'm sorry. Trying to say I don't make a very good window. Hey, watch it. Totally uncool there. Totally uncool. I'm telling you. You just entered my YouTube channel by calling me a door. Thanks. Thanks a lot. Everybody, his name is JD. All right. So there's not a whole lot of work you really have to do here, right? You just need to interpret the graph, or not even the graph, excuse me, the table of values there. So describe what your y-intercept is in this problem. Not what is it. What does it represent? Or what does it stand for? Yeah, how much money, right? How much money did she get? So how much money did she actually get? 125 bucks. Okay. And how much did she spend each time she was there? $25. She's a very consistent driver, right? Okay. Could you graph that? What would it look like if you graphed it? Can you visualize it? What would it look like? It will be a negative slope. I like that statement. What else would it look like? It good. Would it go past quadrant one? No, she's not doing negative gas stops, and she very well could have negative money, right, in a credit situation, but not in this case because it's a gift card, and when it's out, it's out. She's not going to be able to go past that. All right. There are 6 ordered pairs up there. How many of those ordered pairs do you need in order to draw this picture? How many? 2. If you only had one, would you know where the line is going? How many lines could you draw through one point? It's a trick question. No. Yeah, like an infinite number, truly. Now, it would get to a point where it would look completely filled in, but you really can draw an infinite number of lines through one point. But as soon as I add a second point, you know where the path is headed, right? And if I add more that are along that path, whether in between or before or after, they're still in that same line. And I don't really need them. So if you think about the 6 ordered pairs that are up here, and you're telling me I only really need to use 2 of them to make a straight line, which 2 become the easiest 2 to use? Which 2? The what? The top and the bottom? What are those? The top and the bottom in this case are what? What are the X and the Y? The intercepts, right? They really become the easiest for 2 reasons. One, half their order pairs is 0. And 2, you know exactly where they're going to be. One's got to be on the x-axis and one's got to be on the y. You just got to figure out where the number is, whether it's positive 5 in this case, meaning go 5 units to the right. That one may be a little bit harder, right? 125 units up. I guess we'll just count by something bigger than 1. But that idea we're going to take with us moving forward into tomorrow. Like, that's going to be our best bet to graph something when I know that it's a straight line and I only have to use 2 points. All right. So we're going to stop here for today. Your Google form has already been shared with you guys. You guys have a little bit of time. You could do it right now before you leave. All right.